So displacement of something just refers to its change in position. And so you often see it written as displacement is equal to change in x, where x we're referring to the horizontal direction, and then the change in x can also be written in another form. So we're describing the final position minus the initial position. Right, so change in x is equal to x final minus x initial. And so what you need to know is that for displacement of something, you only care about where it started, right, the initial position, and where it ends up, regardless of the path that it took to get there, because that would actually be something else which is known as distance. But displacement is just going to refer to change in x, or another way of writing that is x final minus x initial. And so let's look at a quick example. Say we have some ball here. This is our ball, right? And it's going to roll in the positive x direction 20 meters. So from here down here, let's say it rolls this distance, right? This distance will be 20 meters. And so wherever you set your origin to, that would be 0. So this is going to be our 0 mark, and it travels all the way over here 20 meters. And so how do we find our displacement of this ball? So we take change in x, right, our displacement. Remember, that's equal to x final minus x initial. So what's our final position? Well, we started over here and we ended up over here 20 meters, right? So 20 meters is our final position minus our initial. We set our initial origin to here, so minus 0 meters. So our change in x, or displacement, is equal to 20 meters. And that makes sense because we ended up 20 meters over here to the right side. And again, once I said the origin is going to be equal to your 0 point. And you can set that origin wherever you want. So let's say maybe we set it here in the middle instead. And let's try to calculate this. So we start here in the middle. This is going to be our 0 meter mark. The ball started over here then, which would be, if we're disregarding that 20, this would be negative 10 meters, right? Because our origin is over here. And so we started over here to the left side, the negative side, and we end up over here 10 meters, right? Because the total thing is 20 meters. We just set our origin here. And we could still do the problem like this. And the reason is displacement also accounts for the negative direction because it's a vector, and so if something moves in the opposite direction, then it would still work. So change in x, or displacement, is going to be equal to our final position. So our final position is over here at the 10 meter mark, minus our initial position, right? X final minus x initial. Our initial position is negative 10 meters. So another way of writing minus negative 10 would be to add it. So change in x is equal to 10 meters plus 10 meters. And once again, we see our answer is 20 meters. Because our total displacement from the ball went from here to here, it was 20 meters, regardless of where we set our origin. And now let's do one more quick example. Let's say we have some running track, right? This is a running track. And say we start right here. So this is more of a conceptual question, but let's say we run all the way across this track, right? Do one lap around, and we end up right here. So because our final position and our initial position are the same thing, our delta x would be 0. So change in x would be equal to 0 because our final position was here and our initial position was here. So that minus that would just equal 0 meters. We weren't displaced at all. If we ended up, say here, for example, then we would have some displacement. But because we started here and ended here, our displacement here would actually be 0. And so displacement is just referring to the change in position of something, delta x, and that's going to be the final position minus the initial position.